accessory department improvement at the 210 Shoe Warehouse. So we're gonna start off by giving background on the company. So the company is located in Redlands, California, and was open on June 2007, and is approximately 1 million square feet. So the company is currently going through a downfall right now, and they're seeking process improvement, and that's where we come in. Our focus was in the accessory department, which is about a 37,000 square foot layout of the facility, which contains nine locations from which the pickers can pick from. Anything from handbags to jewelry, anything but shoes is in that department. Sorry about that. All right, so our objective was to help out the accessory department meet their weekly demand of 174,000 units. The importance was to create a more ergonomic layout and equipment for them, and also keeping in mind we want to increase their units per hour daily, and also we want to create a safer work environment for them. So moving on to our flow chart, this is basically the process that the pickers go through in that department to pick the product. It starts off by them walking to the designated area where we stage the carts and the boxes. From there, they'll obtain a cart and obtain empty boxes, place them on a cart from where they will be placing the product in. From there, they'll go through their designated pick path, and once they're done with their designated pick path, they'll finish by walking to the induction line and inducting all those cases into the conveyor belt. And if there's more product to pick, then they'll go back and repeat that process. If not, then they'll end their day or get transferred into another department. This is our current layout of the accessory department at the 210 Shoe Warehouse. We can start off on the top right, where this is where their pick path actually starts. They'll walk to the cart storage and go through the whole entire process, ending on the top right. But one thing that we did see was that there was a lot of crisscross in their paths, and also a lot of wasted walking, which is represented by the gray line, just to walk back to the induction line. So one thing also that we had to keep in mind when we wanted to change the layout is that we couldn't get rid of the bottom section of racks, just due to a conveyor belt being placed on top of them. So it would cost way too much to get rid of that. This is our value stream map. So they receive about 37,000 units per day from receiving. They process about 3,400 units a day, and if that can be processed in the day shift, then it has to roll over into the night shift, which costs the company more money, and they lose the money in that department. From there, it takes about 2 days from when they pick the product to get shipped out of the warehouse.
So we did a fishbone diagram to figure out the causes onto why the demand of 174 units is not being met every single week. So we came up with 7 different causes. 3 of these causes we are gonna focus on, and we are actually gonna find solutions for them. The other 4 we are gonna give recommendations because they are more people. They can only be solved by like the management team and the employees coming together and figuring out a reward system or anything that continuously can improve the communication between them. So the first one that we will be focused on is the layout. The layout right now is too long, it's too confusing, and it takes up too much time for them to walk back and forth. The second thing that we'll be focused on was the racks. Specifically, there's a rack section, the one that Orlando mentioned, that we cannot move. That section takes up too much, it takes up the most time to actually go through the path, and most of the time taken in that section is just by searching for the product because it's too cluttered. The last thing that we'll be focusing on is the equipment, because the equipment right now, the part that they are using to handle the material is too tall for everybody to be able to put their products on. It's also too hard to maneuver because there's no brakes as well, and it only moves vertically, it can't move horizontally, so you basically have to push it.
So here's our first alternative with the layout. As you can tell, the spaghetti diagram looks a little bit less confusing. So basically they start off at the very top, and they go down to the cart storage, which is centralized now. So they go through their whole path, and then they come to the conveyor so that they can go ahead and ship product. And we took into mind the fact that the relationship between the racks, so what's going to be the easiest route for them to pick. And then we also kept in mind the night shift worker employees who stock late at night, so, the top row of racks they're all one-sided, so we kind of thought about they would rack from the back. Whereas the double-sided, they could rack they could, stock in between. So then here's our second alternative. What we did with this one is we took out our conveyor. So instead of the conveyor being centralized, the conveyor is now on the left side. And the cart storage has been moved over to where they first enter. Same thing here. We kind of try to utilize the space as much as possible. So with here, as you can see, the time and the distance definitely reduced. With alternative 1, it reduced about 30%, and then with alternative 2, it reduced about 45% with distance. And then the non-value added time, we went from 11 minutes to 3.16, and then to 3.9.
So based on further research and observations, we were able to determine that 75% of the time that it takes for this process to be completed is being wasted in this space, the blue rack, which is outbound. Lack of organization is evident, and this is due to the fact that the pickers add to responsibility the fact they're restocking the product and actually going to look for the product when it's not in the desired location, which happens very often. As well, there is an error in picking product, as well as product damage and injury incidents due to non-ergonomic principles and found in this department. So for this design, we were able to implement or recommend the implementation of polypropylene dividers. This means that these dividers are designed to be movable, meaning that they can move sideways, they can be removed, or even put back into place when needed. This will allow the department to cope with fluctuation in demand due to seasons throughout the year. As well, this can represent the visual. The yellow marks will represent the actual location of the current polypropylene dividers, and which can help cope with the demand as mentioned. The equipment based on the cart, one of our recommendations based on the height will be to remove or basically stop using the top shelf. This is due to our demographics. The 16 of our pickers fall below the average height, which makes it more prone for them to have an accident due to them handling 25-pound boxes. Also, we use the Neogi equation, which happened to give us a 26.58 range of permissible load, but that is taking into account the fact that it's only the load being handled within our power area. That is not considering the height. So this is why we recommend the removal completely of the top shelf. Also, we recommend the replacement of these middle casters, since they are fixed, which makes the mobility of the cart harder to accomplish. This is why we recommend a Grainger design that allows a 360-degree rotation, as well as a better distribution of load and a better mobility, which is happened explained here. As well, the reduction of loading time will be done by 41%, and this is the actual design, which has also a brake, which can help the pickers stop the cart in case of an emergency or anything that has to be done.
So just to make it easier to see, we continuously ask ourselves the question whether we can decrease